Swayam Prabha. Digital India. Educated India.
Burn the fuels, you get to a carbon dioxide, carbon monoxide. So right. So then what about the carbon dioxide? Again, you are not making the bio waste. Whatever the waste you are generating from your food or whatever industrial thing, you are using nicely for as a fuel. But when you burn, again you are making air pollution. So which means your solution is not over yet. You are only talking about fuels, alternate fuels, but you are not talking anything about the air pollution, which is resulting at the end. Right or wrong? When you burn fuels, you are getting all this carbon monoxide, carbon dioxide thing. So if you can find a solution there also, right? Now you see the green chemistry, everything is coming, everything. So if you can find that solution, okay, you make all the unlimited bio waste, make hydrocarbon fuels, everything you burn unlimitedly, no control, because you have plenty. But if you do that, there is a plenty of pollution is coming. But if you find solution there also, then you don't have to think, right? How much to burn fuel, where to use, when to use. I was telling you just now, yesterday, that you should turn on this, turn off the lights, all thing. I'm telling it's a good habit, okay. But what I'm telling is, when you have unlimited source and you don't see that any like adverse effects of that processes at the end, means there is no poisonous gases or poisonous effects like carbon dioxide you are synthesizing, making when you burn fuels, but even that also you are using for something else, useful things. You don't have to think, right? No waste, no pollution, but you have unlimited energy and unlimited, that is what your sustainable society. You don't have to think whether should I spend this 10 rupees or this fuel, should I burn this fuel or not. You don't have to think. That's what the goal of your sustainable society. So now, but we are in the halfway only. We are making a lot of carbon dioxide using fuels. We found a solution for fuels, but we are still making carbon dioxide. So now let's see, can we use this carbon dioxide as something useful? Even this one carbon, right? That is ultimate goal. So people are doing that. So what is the one good example of carbon dioxide used organic reaction? Or natural reaction. How many of you are biochemists here? Very good. Photosynthesis is not that first time we are doing. Already nature does. Okay. Nature is using carbon dioxide and making all the food what we want. Now, what will interesting thing I will tell you here. If you link. So, what is the photosynthesis? What is this? Chlorophyll, right? Magnesium only. Right? Sunlight, this also sunlight. Okay. O6, I know, find out the formulas, I don't worry. H12, sorry. Very good, very alert, very nice. So you get this. What is this? Carbohydrates, I would say. Because there are many isomeric things, right? So why do you label glucose? Everything is false. Just carbohydrates you make. Now, from here, we did all this, whatever the last 1 hour. We did, we saw that this is coming from bio waste, all those things. What we did? When you burn your cars, vehicles, right? You are getting this. That's what I mean to say. It's a nice cycle you are going to make if you find some reactions. Of course, nature is doing already. But what is the source of carbon dioxide for nature? Suppose 100 years back, we didn't have these vehicles, right? Cars, this one. Only bullock carts and horses people are using. So there is no pollution, carbon dioxide pollution created. Naturally, there is a concentration of all the gases. Okay, but but you see that when you do agriculture and everything, and plants they grow happily and they make all these carbohydrates. Where from the carbon dioxide is coming? If it is keep on using carbon dioxide, as I said, we need to have some concentration of all the gases to maintain this one, what is that? The heating thing. Yeah, very good. That's where when you breathe out, that's you actually exhale out the carbon dioxide, right or wrong? So you are the source of carbon dioxide. Your vehicle is the source of carbon dioxide. So, but you are you exhale out the carbon dioxide in a bio process, okay? And that's the process. So it's what is that? Respiration, isn't it? Your respiration process actually release out a carbon dioxide that your nature uses and makes the carbohydrates. So this is actually a nice cycle. So there is a balanced, right? As you make the carbon dioxide, you at the same time nature makes a good food for you, isn't it? So it's not that you have to make more and more carbon dioxide, but I'm telling you, nature does not live. So for that, you need to have a sufficient number of plants. All you need is a plants. The unfortunate thing, what is happening is, people are more exhaling out more carbon dioxide, plant amount, means the forest deforestation is happening, so number of plants are going, which means that natural process is not happening. So as suppose your population increases, your forest population is also increases. There is a balance actually, but unfortunate thing is we cannot have both of them at the same time. As the population increases, people start cutting forest and to build the industries and houses, all these things, residential things, and that is also going down. So, but if you can actually make the more plants, you don't have to learn anything about green chemistry. All you need to do is plant more the trees, and it doesn't matter how much is your population. But only thing, we don't have a earth, the area, okay, to plant more plants, right or wrong? So there is an imbalance. So in that case, we need to find out some solutions to use the excess carbon dioxide. A simple, nice principle, right? It's a nice cyclic thing. That's what we are also going to see, how we are, other than your photosynthesis, if we can use what is the chemical processes to consume the carbon dioxide, that's enough, and make something useful products from there using that chemical reactions. Okay, there's a lot of chemical reactions are known. There are, don't need to worry about the mechanisms, all those things, but idea is, this is the basis for that. Okay, the natural, this is we can say actually it's a bio-inspired. You learn biomimetic. You don't hear these words whenever you see this carbon dioxide chemistry in okay, but actually this is your biomimicking. The nature is already doing this thing. Carbon dioxide, carbohydrates are coming back to the carbon dioxide. This is going. It's a nice cycle, and we are now trying to mimic using a chemical reactions. We may not be doing exact photosynthesis. Okay, there are many ways to do the artificial photosynthesis also, but we can do even other chemical reactions also using carbon dioxide. That is the idea. Just if you this because these are slides that prepared for my class, because I have about 40 hours class, so I can give them more details coolly. But we don't have much time here to go through all those things. Okay, doesn't matter. So a lot of source is there. So I don't have to give you more all the information. How much you generate the carbon dioxide every year. Lot of things. Okay, so there is no problem for a carbon dioxide source. You don't have to worry that you have someday you have to generate a carbon dioxide. It is there. Excess, already excess is there. You only find the ways to use. I'm just giving you a simple chart. One simple chart. Okay, this is one from one review article, that carbon dioxide, how many different types of reactions you can use. You have never learned this carbon dioxide based chemistry, right? Actually use once in a while, but you people don't remember. What is that two chemical reactions you learn with carbon dioxide? Coal based. What is that you said? Coal based reaction is there, right? Where from a phenol to salicylic acid you synthesize, right? That is one. And other one is carboxylation. A Grignard reaction, alkyl lithium, you pump the carbon dioxide, you make the carboxylic acids. These are very simple reactions, but you never pay much attention to the carbon dioxide there, right? That you are actually consuming carbon dioxide, and that is you are doing a green chemistry reaction there. And but there are many other reactions also you can do that. So there is a coal-based reaction. Okay, many interesting reactions you can do using carbon dioxide. That's what I just listed. This already we have discussed. Okay, many things we can do. Even urea you can synthesize from there, and the dimethyl carbonate, because this is one of the linker in the polymerization reactions where you make a polycarbonate synthesis. Okay, so that's what people use, a lot of polymeric material, polycarbonate based polymeric material. Okay, like in place of this chloride. Okay, what is it? Yeah, so you can use this dimethyl carbonate. Okay, that's okay. Yeah, so there is, I will just give you one important application of this one. Other than the making a simple organic reactions, one type of products what you get from carbon dioxide, which are nothing but carbonates or polycarbonates, which actually we use in our day-to-day life also as a lot of replacement for your polyethylene and other things. Okay, so they do not conduct electricity. These polymeric materials, high heat resistance, durable, strong, usable in wider temperature range, flame retardant, easier to mold, highly transparent, and these are the things actually people are now, these are the things we are using, right, day-to-day life, and they are actually polycarbonates. And the polycarbonates comes from the reaction of carbon dioxide with some other building blocks. There are many building blocks people use, but one of the reactant is carbon dioxide, and you synthesize the polycarbonates, and these are the polycarbonate materials which we are using in our day-to-day life. Okay, which means carbon dioxide is becoming converted into something useful products, right? So many materials we use, these are all polycarbonate materials only. And that's what I was telling. How that happens is the even one step ahead. People make this one of the reaction between the polycarbonate synthesis is carbon dioxide and the epoxide. Okay, I will give you one reaction mechanism. But when you do that reaction, you make a carbonate. Okay, or polymerization. If you do polycarbonate, you synthesize. And even these epoxides people get from the bio sources, bio waste. We have seen, right? A similar kind of bio waste, because a lot of bio waste has the olefinic alkanes, means alkenes, and you do the alkenes, the epoxidation, and that all this waste, epoxidized waste, bio waste, and you can react with the carbon dioxide and make something useful. Carbon dioxide is a waste, and you are taking a bio waste based epoxides, combining them and getting useful products. This is already in place in an industry, people are doing, and that's what the products we are using. Without that, we don't use. This is already we are using, right? All these products, and these products are nothing but polycarbonates only. Okay, and the interesting thing here is why these are more important here is once you cleave them. Okay, this is something called degradation. This is also one of the green chemistry principle. You need to. It's not that you make a compound, material which is useful for you, but at the end of its use, it should be able to degrade. That's what one of the green chemistry principle, right? So here they will get easily degraded because they have lot of carbon oxygen bonds and ester functional groups. Just you throw these materials into the environment, you have a sunlight, soil is there. In the soil, you have a lot of metal complexes are there. Okay, and you have water. Everything is there. So there is a source for simple chemical reactions to happen, and they degrade. But you may be worried that, sir, if they degrade into make the small molecules, what happens? The small molecules also can be poisonous, right? No problem, because these small molecules came from nature only. So nature knows how to handle them. Anything comes from a nature. Nature will have a prescription for it, how to handle, how to keep it quiet. That's why people always say that you follow biomaterials, bioproducts. What it means is nature knows. You are getting from a nature only. You are throwing into nature. So it knows how to handle. Only thing, if you make an artificial compound which does not exist in the nature and you throw into the, that's what polyethylene. I'm just telling you, give an example. Nature doesn't know how to do the chemical, decompose it. So that will be a poison for it, nature. That's a simple principle, nothing more than that. So, but here nature knows. The building blocks, what is generated after the decomposition, it knows how to handle it. So, no problem. You understand? Like we have seen that biofouling agents, the tin oxides were used as a biofouling agents for the boats and all, right? The tin is artificial, so the C creations doesn't know how to handle the tin based reagents, but people come up with a natural product based biofouling agents, which means it's you are extracting from nature. So there is a prescription, there is a principle know to how to handle these molecules. Once you throw into the nature again them, okay, and the fishes or takes anything, so they have the memory how to handle it. Like mosquitoes, when you use that's why you see every day you see that powerful this mosquito repellents will come, all those things, right? Why every month you see a upgradation of their power? Because mosquitoes will get used to it. Once they are getting affected by some formula, so they keep that memory and they know, so then they start developing the resistance. Okay, so when the next time the same chemical, the mosquito repellent comes, they see they already develop the resistance in their body, which means they have the prescription for it. So that repellent doesn't work on them. Simple principle. Same thing here also. That's why people, again industry after a few months they say that this is more double time, 2x, 3x, they say that more powerful than this one. Why that? Because the insects are getting their prescription, means how to handle that repellent. So you need a new repellent, right? That is sort of vaccines, everything, right? So the same principle here also. So nature will have the principle how to handle them. So if you get the building blocks from the nature and use your make your products and throw into the nature also, there is no harm. That's why biopolymers, bioplastic. Why that bio is coming? That indicates that the ingredients have come from the bio nature. Biological waste or maybe edible, non-edible, whatever it is, it came from a nature. So there is no harm. Otherwise, if you look at the polyethylene bag and this one bioplastic, looks same only, right? But then did you ever think that what is the difference in that? How only that part that will create a problem to the nature, but not this one? Simple principle, the ingredients are coming from the nature. Nature knows how to handle it. That's all. Got it? Very, very important. That's why we need to work with the nature and don't go anything against the nature. Whether it is rain, sunlight, or your winds, anything. That's why our house construction also, how they do, depending on the area, the entrances direction will change. Depending on the sunlight, where you are building house, the wind power, how the wind direction, all those things they consider, they accordingly they build. Okay, in Chennai, you people build north to south mostly houses. Okay, so south and west. That's what I have seen most of it. And if you go to our place, I'm telling you, we construct our entrances towards the east and the north, because that locality is like that. They get the more better light and wind. So we should not go against the wind direction. Okay, you should be in line with the wind direction. That means you are safe. So all this is nothing like if you go to some Achari, he will give all this. It's just science. There is something science, okay, but they may not be understanding, you may not be understanding, but these things are set up many years back. Okay, only thing they don't reveal. Every time you cannot tell everyone that because of this we are doing. No need to tell. They said, hey, you follow this blindly. That's what we are doing, many things, and sometimes we say that we don't understand why we have to do this, right? But there is some logic behind that. Anyway, doesn't matter. So as I said, the carbonate synthesis from carbon dioxide, there are many methods, but you see the carbon dioxide, carbon dioxide, carbon dioxide, carbon dioxide, carbon dioxide. So out of these many methods, 1, 2, 3, 4, 5, you see the epoxides, olefins, propoxylic alcohols, halohydrines, diols, okay, and many things. You can see that even this also comes from a carbon dioxide, again diol. So which means out of this many methods of preparing carbonates, most of them are coming from carbon dioxide. Okay, so there are all these methods gives these cyclic carbonates, and these cyclic carbonates actually are useful in this synthesizing all these materials. Just now I shown you. Okay, so which means more importance is given now these days for a carbon dioxide based chemistry, particularly the carbonates synthesis, whether it is a cyclic carbonates or polycarbonates. For carbon dioxide is used as one of the key building block, and you have plenty of the source. Okay, so I will not give all those things are mechanisms, but one interesting thing is, oh, many reactions are there. You can see that how many, I have related a lot of chemical reactions also, many reactions, many nice reactions. If you learn all those things, it's like a nice organic chemistry only. Okay, whatever you learn, but with a carbon dioxide. That's all. So it's we teach about 10 hours to learn this carbon dioxide in our course, the green chemistry course. Many interesting reactions, yeah, but this is important. Okay, but so we want to use a carbon dioxide, that's fine, but can we use just like that? Suppose you are burning a fuel in your vehicle, car or scooter or whatever it is, you get the carbon dioxide, can we use as it is? No, because it will contain a lot of other things, unburned, like alkanes also will be there, other gases will be there, many things. So you need to purify that. Okay. That's why if you go and see any laboratory, people use carbon dioxide chemistry, they buy cylinders. It's a purified, concentrated carbon dioxide gas. Nothing, but where is the source? Whatever you burn the fuels, that is the source. So from there they purify. Okay, how do they purify? There is one nice simple technique to purify such kind of things. Okay, that's what carbon dioxide capture. It came about 4 or 5 years. Though it's a simple reaction, even after reading this paper, I also wondering how come people are not aware of this simple technology before. What it does is, you burn something. Okay, these are all the gases will be there. When you burn a hydrocarbon, you get lots sorts of fragmentations. It's not that you don't think that everything it will be converted into a one carbon units and all the carbon dioxide will be there. You can maybe getting a propanes, propoxides, ethanol, all those things will be there. You are burning with oxygen, that's all, right? So all sorts of things, but you need only carbon dioxide. What they do is, they take this exhaust gas what after burning and add into the amines. Okay, simple, they take a secondary amines, primary amines, okay, in an aqueous amine, and they pump all this mixture into that big reaction vessel. So what happens when you have amines and carbon dioxide? It's a simple acid-base reaction happens. Carbon dioxide is a Lewis acid. How many of you know? It's a good Lewis acid. Okay. It's amines you are adding. So just acid base, a complex, okay. This is what happens, that's what I have shown you. If you write the proton here, okay, you have lost this proton, right? Let's put this. Carbamic acid. They are not very stable, but they form, like your carbonic acid, H2CO3, carbonic acid, right? So it forms, but it is not very stable. It will quickly form the water and carbon dioxide. Same thing they form. So what they do is, so they use this simple principle. You take a combustion based carbon dioxide, all the mixture, and transfer into a reaction vessel which is having a ammonia, so like amines. So what happens is amines reacts with only with your carbon dioxide. Remaining all will be gone. You can filter out, if the solid materials are there, you can filter out. The remaining small gases will go away. So you will get nice this kind of carbamic acids. You can separate them out with a simple filtration and this one. Okay. And now you keep this one in a vessel. Okay. And make a outlet. You want to do, you use a carbon dioxide based reaction. Okay. Take your reaction vessel. Okay, you may be saying this, how, what will I do? Don't take that directly from the reaction, this the bulk vessel. So you take some amount, this is a solution, right? So amine and carbon dioxide solution this is. You take, suppose this is a, suppose 1,000 liters is there. So you need only 2 ml. Syringe out some 3 or 5 ml of this, transfer into a small RB, okay, suppose, another RB. So this mixture will be there here. And now this is at a room temperature, usually they store, or even low temperature also, slightly, just to make sure this bond exists, it doesn't decompose. Okay, but when you need you need to break this bond, right? You just heat it slightly. Okay, instead of room temperature, just heat it to a 40 degrees, 40 degrees. the NCO bond is very weak, as I told you, it just goes away. It's like your dative bond only. So what happens is, now you make R2NH plus CO2 gas here, and the gas will be coming and going into your reaction. You understand? So you make the crude carbon dioxide, okay, and purify it using this means, okay, and that you use as a source of your carbon dioxide for your organic chemical reactions. Whenever you need, you take from that vessel slight some amount and heat that, but before that you connect it into your reaction flask and heat it. So Mn will be in the flask, carbon dioxide will be going in the form of carbon gas and to the reaction flask. Your reaction happens there. It's a simple principle, and that you can use actually from the gases what you get from your vehicles. That's what combustion. When you burn anything, okay, and what the mixture you can take and you can. This is a nice concept, but unfortunately I don't know. So people have not. This is about 2019 also, some paper. This paper came. So a very interesting thing. So you can purify carbon dioxide also. Okay. Is that okay? Yeah. Just I don't want to give the chemical reactions, but that is the idea. But I will give you one small thing, because I was telling this plastic polyethylenes. So there is a solution also now. Okay. So far we have a problem with this, how to decompose. It doesn't decompose. If you throw this bottle, if you after 10 generations you come back and see, also still it will be there. Okay, it doesn't decompose. Okay, but now you can do the decomposition of this. In a laboratory, you can actually decompose this into a small molecules. There are chemical methods, exist simple chemical reactions, nothing more. Okay, so I don't want to take more time. So just a small history about the polyethylene and polypropylene. Okay, 1933. It's now we are nearing the century of the plastic. The is first synthesized, but of course it came only in the 1950s into the market. Okay, and I think in India it came only in the 90s. Yeah, when I was in school only I saw the plastic. Before that we used to go to the shops and they give in the paper only. Paper packets, or if you want to get oil you need to carry the steel can. Otherwise there is no way you get anything. I am telling you, there was no plastic. Maybe in my 10th or plus 1 I saw these plastic bags coming. Before that we have not seen. Maybe in a towns it is there, but in villages we have not seen anything. So, but within these 30 years, now it became a big headache for us how to stop this. Okay, whatever it is. So this is the history of it, and there are various types of polyethylenes. High density polyethylene, low density polyethylene, linear low density polyethylene. Now, when I say linear specifically, which means this high density low density can be a non-linear also. Don't think that it will be a linear polymerization. It will be a cross-linking also. That's what I mean. So there are specially linear polyethylenes also there. So once you do all these things, what they differ is, they differ in their melting points and their strength. So depending on your requirement, whether you want to make a bottle or with the oil can or maybe other material, accordingly you need to choose the plastic, the different types of polyethylene, and that will result in the useful properties. That's why the different types of these are there. So its formula is C2H4, right? So what is the structure? Can anybody write? Because when I asked this one in my final exam, half of the students have written the wrong structure. Polyethylene structure. This is the building block, ethylene, polymeric ethylene. Whether you will have a double bonds in the polymer or not? No double bond. How many of you raise your hands for no double bonds? Raise. I told you at the beginning, when you decide something, speak out loudly. Let it be a wrong. But don't be arrogant and don't be adamant that this is only right. Just say that, raise your voice strongly, that's it. Why? Remaining students, you think irukum. Okay, no problem. So it will be there, you think. Sure. If what is the problem then decomposing if you have a double bond? If you have a double bond, That is the source of every functionalization. You can do epoxide, you can do halogenation, you can do many things, and once you have a heteroatoms, I told you last class also, anywhere you have a heteroatom bond, it's easy to cleave. That was not there, that is the problem with polyethylenes. It's a polymerization, okay, that happens through the double bond cleavage. CC sigma bond will be there, the pi bond will be converting into the another, makes another bond with another unit. Okay, so when you make suppose CH2, so there is a CH2, suppose this is the one unit I said, between these two I need to make a sigma bond, right? So for that I need to disturb the pi electron density. Carbon cannot have 5 bonds, it can have only 4 bonds, right? So it's already 2, I want to make one bond this side, it has to lose one bond here, and that's what happens. So it is a only sp3. Okay, no double bonds. That's why the double bond is used to make the polymerization. Otherwise, what else is it? You are not breaking the CH bonds in the polymerization. You are making breaking CC bond, CC pi bond, and making CC sigma bonds. You are not doing, you will keep the same number of hydrogens, same number of carbons. Only thing, the pi electron cloud will be used to make the sigma bonds. Okay, that is a polymerization. That's what I asked. So same thing, my students also thought, half of the students has written the wrong structure. The formula is same. Same thing, you see the CH2, CH2, CH2. You are neither adding any atoms nor removing anything. That's why N will be there. Only thing, since you are making extra sigma bonds, you need to lose the original pi bonds. That's all. Right? Got it? Yeah, don't get confused. Anyway, I have next slide the structure. So these are the materials we use from the plastic, okay? All the things, yeah, that's what the structure, ethylene and this one. Okay, don't think that double bond will be there. If the double bond is there, we are happy, actually there is no problem. Remember this. Okay, if any unsaturation, any heteroatoms are there, it is easy to do the functionalization at that center. So there is no problem. Okay, good, don't worry about it. So now what people are doing is, there is something called upcycling. You might have heard recycling. So what is the recycling? Using, suppose a bottle is there, take it there and convert into again the bottle only, recycling. Okay, mostly that same properties, they don't change any of them. Okay, this material they will keep as it is and they will make a same structure will be there, but a different product they will make. Upcycling is slightly different, it is a chemical term. What you will say, you take a bottle, it has some structure. Okay, you will not keep the structure intact. When you take the plastic bottle and cut into a small different pieces and use these small pieces into something useful. So which means you are actually changing the structure of original plastic. That is something called upcycling. Okay, it's the reuse only, but it is slightly different from your recycling, reuse thing. There, as it is, people use, they don't change that. That's why the people collect the plastics, right? Of course, they use for multiple purpose, but when you say recycling, they don't worry don't change the chemical structure too much or the properties of the material. So they will make the different products with the similar properties. Okay, the polymeric properties they don't change, but here they cut into a small pieces. Okay, and they make different products. This is slightly different one. Reuse only, but this is called upcycling. So you make a different building blocks from there. Not necessarily what you started with. Okay, originally it's like here polyethylene is the original point is ethylene. You don't make a ethylene, but some other building blocks, C10, C20, many things people make. I'm telling you. So that is something called upcycling. So that's what this is the process of transforming byproducts, waste materials, useless or unwanted products into a new materials or products perceived. That's what I'm saying. A better thing, not exactly what you have. Okay, so that how do we do this? Polyethylene upcycling. People are doing that. Okay, upcycling means they are actually doing some reactions at the polymeric material and making some small things which was not there earlier. Because of that, we are throwing plastic and they are hanging. Now you don't need to worry actually. You can collect the plastic bottle. That's why you will see a lot of places also. They say that you put one bottle, you get a 1 rupee coin something. It's a good way of recycling actually. Okay, so they want to get all the plastic back, so that they can do all this upcycling or recycling and they can make new products with a less cost. That's better. See, what it is it's all about chemical reactions. See, don't think that polymers and these materials means something. This bottle has only a carbon and hydrogen bond. Carbon bond and carbon. Just think as a chemist. That's all. Don't think that as a bottle or something object, something different. This computer has again some silicon, some other materials. If you start looking as a chemist, you see only elements. Once you start seeing as every object as an element, you will find some lot of new things in that. Okay, so don't think as a big object. It's after all a chemical entity. Okay, that's what it is. So this is the structure of your hydrocarbons, polymer, polyethylene, polypropylene. What's a long chain alkanes, right? So far the problem is, since all the CH bonds, CC bonds are very strong, so we cannot, they don't undergo the rapid reactions under normal conditions, okay. So their decomposition is fast. Decomposition means making into small pieces. So now chemically people are doing. So iridium is good at this, iridium metal, very good at doing this. If you learn about the iridium catalysis, you will know that it actually make a agostic interactions with the CH bonds. It just directly inserts in the CH bond and activates. That is very special property of the iridium. And that's why you see the most of the places iridium is used. So what it does is randomly reacts with the CH bonds. That is a special property of iridium, different oxygen states. And now you see that it creates the double bonds. It inserts and gets eliminated. Oxidative addition, reductive elimination. You learn your inorganic chemistry, right? Organometallic chemistry you learn, right? These things. So it inserts and comes out. And during the process it creates a double bond. Just now I told you, if you have a double bond, that is the source of every reaction. That is okay. Then once you have that, you can do a cleavage everywhere. So now the polymeric metal into becoming a small molecules. Isn't it? You are breaking each, wherever the double bond is there, you can cut over. No more a polymer. That's what this upcycling thing. So here, when you cut, you can get maybe a ethylene here, propene. So meta this you are doing. Different alkenes and different unit. You are not going back to the original ethylene. That's what I said. It's upcycling means you get into different building blocks. But all of them will be useful. And like that, many reactions are there. Just I am showing a slide from a review article only, because I don't have time to details all these things, but I am telling you how that people are doing. So this is the simple chemical reaction. This is, when I say this is the plastic bottle. Assume this is a plastic bottle. It's not a simple thing, okay. So I am taking a plastic bottle and doing this reaction. Of course, not like that. Just we have to make a crush it and make some powdery kind of thing so that we can do a reaction, okay. And this is what the functionalization happens. And not only that, take the hydrocarbons. In presence of light, you can do the halogenation reactions. You people learn, right? The propagation, the termination, initiation, the radical halogenation mechanisms with the alkanes. Same thing you can do, and you can insert a halogen bond, CX bond. One CX bond is there, you can do anything. Alkyl halide chemistry, you go and learn your +2. How many types of reactions you can do? Everything you can do. Either you can create a double bond, you can do a hydroxylation, alkoxylation, anything you can do, right? So which means you are creating a reactive center. This is what was lacking earlier. All you need to decompose the polyethylene, you need to make a reactive centers in the polymer. So that itself will decompose. But naturally it is not possible, but chemical people are doing this. So now you see that many interesting things. So you see that small molecules they are making from this. Okay, it's not that I'm just joking. All these materials there, if you see some research papers, they take these materials. They practically do in the laboratories. They crush it and they do the reactions. Then they analyze how much extent they are doing this unsaturation or halogenation. All this, these are research papers I'm talking. So people take this. It's not that they take some ideal polyethylene somewhere purchased from industry or not like that. The routinely used, daily used plastic materials, they have to test. They will be testing this. And they do all these chemical reactions. That's all. That is about it. But that is what actual people are doing. So nowadays, the polyethylene or poly are not a problem at all. So we can actually decompose them. Only thing, make sure you don't throw into the nature. collect back and you can decompose. Okay, earlier even if you collect also, they will be piling up as a waste only. But now there is no more waste. You can actually do some chemical reactions and reuse them. Okay, that's all about this. So I will stop it here.
SwayamPrabha, Digital India, Educated India.